Now we will look into this particular topic called as impedance matching, which is very important for maximum power transfer from a certain source to a particular load. Earlier we have seen for the resistive case, when you have a certain resistive load impedance and a certain source with a particular source resistance, we saw that the source resistance and the load resistance have to be equal for maximum power transfer. In the case of generalizing that concept, in the case of having a complex load impedance and a complex source impedance, we know that the reflection coefficient at the load is going to be ZL minus ZS over ZL plus ZS. And if ZS and ZL are not the same, then this reflection coefficient is not equal to 0. So, how to have a maximum power transfer in such a scenario where the power is transferred from the source to that particular load? The procedure to achieve that is called as impedance matching, and it is done by inserting a particular two-port network called as a matching network. The matching network's objective is to transform a certain load impedance to a particular input impedance that the source sees, such that the source impedance has a particular relationship to the input impedance. Turns out that when the source impedance is the complex conjugate of the input impedance, that's when maximum power transfer happens from the source to the load. That means the real part of the source impedance must be the same as the real part of the input impedance. The reactance of the source impedance must be the negative of the reactance of the input impedance. It is important to note the conjugate there. The same concept can be extended to the case of a particular load with a transmission line feeding that load impedance. Similarly, in this case, the impedance matching network transforms a particular load impedance ZL to the characteristic impedance of the transmission line, which is usually resistive and typically 50 ohms. So this matching network transforms the ZL to Z0, and here the matching network transforms the load impedance to the conjugate of the source impedance. Thereby we can achieve maximum power transfer from a particular source to the load.